For all of human history, the moon has been our silent, constant companion in the night sky. We've seen it as a deity, a destination, and, well, a dead world. But recent events have shattered that last perception. A groundbreaking discovery by China's space program has confirmed that our moon is not a static relic, but a dynamic body teeming with resources that could, honestly, redefine humanity's future, turning science fiction into scientific fact. So, what did they find, and how does it connect to the decades of mystery surrounding our moon? Let's dive in. Anomalous lunar structures. The conversation about inexplicable objects on the moon often circles back to a single pivotal mission, the 1994 Clementine mission. This was not a standard NASA science mission. It was a joint project with the United States Department of Defense's Ballistic Missile Defense Organization. Its official purpose was testing advanced lightweight sensors by mapping the moon, but its military oversight has, fueled speculation that its agenda was more than purely scientific. From the massive trove of 1.8 million digital images it sent back, a few select frames have become legendary within circles that investigate lunar anomalies. These images, especially from the perpetually hidden far side of the moon, appear to contain features that defy easy geological explanation. There are patterns that look unnervingly geometric, with straight lines and sharp 90-degree angles that some interpret as the weathered ruins of immense ancient structures. The most famous of these is a feature that strikingly resembles a massive three-sided pyramid. While the scientific consensus attributes these oddities to a combination of digital image compression artifacts and the deceptive play of light and shadow across an alien landscape, many researchers remain unconvinced. They point to what they see as signs of deliberate censorship, like patches of unnatural blurring or obfuscation, suggesting that the Clementine mission was, in fact, a reconnaissance flight to get a closer look at something that was already known to be there. Ancient astronaut connections. The intriguing possibility of lunar ruins feeds directly into the wider, captivating theory of ancient astronauts. This hypothesis suggests that intelligent extraterrestrial species have been visiting Earth for millennia, and that their influence is recorded in our oldest myths, artworks, and sacred texts. This lens reinterprets our history not as a story of primitive superstition, but of misunderstood technology. For instance, a persistent piece of UFO folklore is a supposed secret transcript from the Apollo 11 mission, where Neil Armstrong allegedly expressed shock at seeing massive alien craft and structures. A story that has been thoroughly debunked by NASA but, continues to circulate. This narrative is woven into reinterpretations of ancient texts, such as the Sumerian cuneiform tablets. In one tale, a godlike being from the Anunnaki advises his son, before a journey to the moon, to wear his eagle's mask. Proponents of the theory argue this is a clear description of a helmet, a piece of life support technology. This same re-examination is applied to ancient art across the globe, most notably the Wandjina cave paintings in Australia. These ancient artworks depict beings with large, dark eyes and heads surrounded by a halo-like ring, which look remarkably similar to a modern astronaut viewed through the visor of their helmet. The question the theory poses is a powerful one. Were our ancestors painting gods, or were they painting visitors? China's groundbreaking discovery. Moving from compelling theories to verifiable facts, China's space program has recently delivered hard, verifiable evidence that is, in its own way, just as revolutionary. The nation's Chang'e 5 mission was a masterpiece of robotic engineering. In December 2020, it successfully touched down in a previously unexplored region of the moon, drilled into the regolith to collect samples from beneath the surface, and then returned 1,731 grams of lunar material to Earth. It was the first time in 44 years that humanity had brought back a piece of the moon. After more than a year of intense analysis, Chinese scientists made two monumental announcements in 2022. The first was the identification of a completely new mineral, a phosphate crystal they named Change Site Y. This placed China in an exclusive club with the United States and the former Soviet Union as one of only 3 nations to have discovered a new lunar mineral. The second discovery, however, had even more profound implications. They found definitive proof of water, not as ice, but as molecules trapped inside tiny beads of glassy material forged in the heat of ancient asteroid impacts. This finding completely changed the scientific understanding of lunar water, proving it wasn't just isolated at the frigid poles but was, in fact, distributed far more widely across the moon's surface. revolutionary implications. So, this confirmation of widespread water on the moon is honestly a watershed moment for the future of human space exploration, because it really validates the concept of in situ resource utilization, or ISRU. That's the principle of using local materials to create what you need to survive, instead of hauling everything from Earth. For decades, the dream of a permanent lunar base just seemed totally out of reach, mostly because of the massive costs involved in launching all the water, oxygen and fuel required. But China's discovery, well, it completely reshapes that calculation. Even though each glass bead contains only a tiny amount of water, the sheer volume of lunar soil means there could be as much as 270 billion metric tons of water up there. Future missions could send rovers to heat the soil, releasing the trapped water as vapor, which could then be collected and condensed. This water would be absolutely vital for drinking and for irrigating crops in lunar greenhouses. And perhaps even more importantly, electricity can split the water into its base components: breathable oxygen for life support, and powerful hydrogen for rocket fuel. This really transforms the moon from just a desolate stopover into a self-sufficient exploration hub, and honestly, a fully functional gas station for missions heading deeper into our solar system. The Chang'e program evolution. China's lunar triumphs aren't just the result of a single lucky mission. They're actually the culmination of a patient, multi-decade, and brilliantly executed strategy called the Chinese Lunar Exploration Program, or CLEP. This program was designed as a deliberate three-step progression, each step more complex than the last. The first step was becoming a lunar satellite state, pulled off with the Chang'e 1 and Chang'e 2 orbiters. These missions created high-resolution maps of the entire lunar surface and identified potential landing sites for the future. The second step was achieving a surface landing, and that milestone was reached in 2013 with the Chang'e 3 mission, which deployed the U-2 rover, a major national achievement. Then China showed off its advanced capabilities with the historic Chang'e 4 mission in 2019, pulling off a world first by successfully landing on the far side of the moon. That took a dedicated relay satellite to solve the communication blackout problem. The third step, which was the most complex, was sample return. The Chang'e 5 mission nailed this in 2020, performing a landing collection, a launch from the moon, a robotic rendezvous in lunar orbit, and a safe return to Earth. This methodical step-by-step approach has really shown without a doubt that China has arrived as a top-tier space power. Resource revolution on the moon. The samples returned by Chang'e 5 have honestly unleashed a scientific revolution. They've recast our view of the moon, so it's not just a geological artifact anymore. It's a vast repository of strategic and economic resources. The discovery of the new mineral, Change Site Y, is more than just a novelty. It's significant because it's a phosphate mineral containing helium-3, which is extremely rare on Earth, but has been sprayed onto the moon's surface by the solar wind for eons, getting trapped in the top layer of regolith. A lot of physicists consider helium-3 to be the ideal fuel for nuclear fusion, which is like the holy grail of energy production. Fusion reactors powered by helium-3 could generate huge amounts of clean energy, with no greenhouse gas emissions and none of the dangerous long-lasting radioactive waste you get from today's nuclear fission plants. The ability to mine helium-3 on the moon could, one day, actually secure humanity's energy future. Beyond that, lunar soil is also rich in rare earth elements, which are vital for making everything from smartphones and electric cars to advanced defense systems. So, the moon could become a critical source for these materials, helping to ease the environmental damage and geopolitical tensions that come with mining them here on Earth. Future lunar colonization. With the confirmation of accessible water, a potential source of near-limitless energy from helium-3, and abundant construction materials, the vision of a permanent human settlement on the moon has leaped from the pages of science fiction into the formal strategic planning of major world powers. This vision took a significant step toward reality in March 2021, when China and Russia officially announced a joint partnership to build the International Lunar Research Station, or ILRS. This is a profoundly ambitious project to establish a permanent and eventually fully autonomous scientific outpost near the moon's south pole. This location is highly strategic due to the presence of large quantities of water ice believed to be trapped in its permanently shadowed craters. The ILRS is designed to be a hub for scientific discovery, technology verification, and large-scale resource extraction. It will serve as the crucial proving ground for the systems and technologies necessary to sustain human life for long durations in the harsh environment of deep space. And underscoring the seriousness of this commitment, Chinese space officials have stated their intention to have a nuclear power plant operational on the Moon by 2028 to power the station's construction and early operations. Lunar resources, the new gold rush. The definitive discovery of vast and valuable resources on the Moon has officially ignited a 21st-century gold rush. This has created an intense geopolitical competition to claim and control the most strategic locations, turning the lunar South Pole into the most sought-after real estate in the solar system. This land rush, however, is taking place in a dangerous legal vacuum. The foundational treaty of space law, the 1967 Outer Space Treaty, is clear on one point. It explicitly prohibits any nation from making a claim of sovereignty over the Moon or any other celestial body. No one can own lunar land. However, the treaty is critically vague on the issue of resource exploitation. It does not provide a clear legal framework for whether a nation or a private company can mine lunar resources and claim ownership of them. This ambiguity has created a high-stakes race where the prevailing logic is that possession is 9/10 of the law. Nations are now rushing to establish a physical presence, to land rovers, build habitats, and demonstrate resource extraction, in the belief that these actions will establish a de facto precedent, strengthening their position in future negotiations over who gets to write the rules for the lunar economy. International space race. Today's race back to the Moon is a fundamentally different beast from the two-horse race of the Cold War. It is a global, multipolar, and heavily commercialized affair. One of the principal efforts is led by the United States through NASA's Artemis program. The goals of Artemis are not just to repeat the achievements of Apollo, but to go further by establishing a sustainable, long-term human presence on the Moon, with a landmark commitment to landing the first woman and the first person of color on the lunar surface. The defining characteristic of the American approach is its deep and unprecedented partnership with the private sector. Instead of developing all of its own hardware in-house, NASA has embraced a commercial model awarding multi-billion-dollar contracts to companies like SpaceX and Blue Origin to build the landing systems that will carry its astronauts. This collaborative philosophy is legally enshrined in the Artemis Accords, a US-led international agreement that sets forth principles for peaceful and transparent cooperation in space. With dozens of signatory nations, it forms a broad coalition built on a shared vision, standing in contrast to the more state-centric models of its global competitors. Competition between China, US, and other nations. The geopolitical chessboard of this new space race is rapidly organizing into two primary alliances. In one corner there is the US-led coalition of nations that have signed the Artemis Accords, which includes established space powers like Japan, Canada, and the member states of the European Space Agency. In the other corner is the burgeoning partnership between China and Russia, centered on their ambitious plans for a joint international lunar research station, which is steadily attracting its own international partners. However, this is not a simple bipolar conflict. Other nations are carving out their own paths and emerging as significant independent forces. In a spectacular display of technical skill, India's Chandrayaan-3 mission made history in 2023 by becoming the first nation ever to achieve a soft landing near the lunar South Pole. This historic achievement instantly established India as a major player and a critical contender in the search for lunar water ice. The current landscape is a complex and dynamic interplay of national ambition, commercial interests, and strategic alliances. While intense competition is currently driving innovation at a breathtaking pace, the sheer crushing difficulty and expense of operating on the Moon may ultimately force these rivals into a new era of global cooperation. The Moon is no longer just a beautiful light in our sky, it's a destination, a resource depot, and a critical stepping stone to the rest of the cosmos. China's discoveries have opened a new chapter in human exploration, one that will challenge us technologically and force us to decide how we will explore these new frontiers together. What do you believe is the most important resource the Moon has to offer? Share your thoughts in the comments. Don't forget to like, subscribe, and hit the bell icon for more explorations into the science and wonder of our universe. Thanks for watching Sci and Why. After 46 years of traveling through space, Voyager 1 finally sent back data from beyond our solar system that nobody saw coming. This isn't just another space mission update, it's a complete game-changer for everything we thought we knew about the universe. The tiny spacecraft has crossed into interstellar space and discovered an environment so strange and structured that scientists are, honestly, rewriting their textbooks. Get ready to have your mind blown by what's really lurking in the darkness between stars, because the truth is absolutely incredible. The Great Silence and Revival. Space exploration hit a terrifying moment in late 2023 when humanity's most distant messenger went completely silent. Voyager 1, our faithful explorer that had been sending data for nearly 5 decades, suddenly started transmitting nothing but garbled, meaningless signals. Engineers at NASA faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away. The culprit was a corrupted memory chip, likely destroyed by the same cosmic rays Voyager was studying. The fix required rerouting decades-old code into backup systems while dealing with a 22-hour communication delay. By April 2024, the impossible happened. Voyager came back to life, and what it began transmitting would change our understanding of space forever. The magnetic revelation. Something extraordinary happened when Voyager's magnetometer came back online. It revealed that space between stars operates by completely different rules. The spacecraft detected an interstellar magnetic field that's dramatically misaligned with our sun's magnetic influence, suggesting Voyager has encountered a galactic-scale boundary zone. These aren't minor variations. They're fundamental structural differences that point to magnetic turbulence zones where galactic fields twist and reconnect in ways scientists never predicted. The readings indicate Voyager might be navigating through invisible cosmic highways where magnetic forces create pathways and barriers throughout our galaxy. This discovery means the Milky Way has an underlying magnetic skeleton that influences everything from star formation to the flow of cosmic material, and we're only now getting our first direct measurements of this hidden architecture. The Cosmic Storm. The moment Voyager 1 crossed the heliopause in 2012, it encountered a radiation environment so intense it would be lethal to any human traveler. High-energy cosmic rays, accelerated to nearly light speed by distant supernovae and black holes, bombard the spacecraft at rates dramatically higher than anything measured inside our solar system. The jump wasn't gradual, it was like stepping through an invisible force field into a cosmic shooting gallery. These measurements reveal that our sun's protective bubble shields Earth far more effectively than anyone realized, creating a cosmic oasis in what's essentially a galaxy-wide radiation storm. The pattern of these particles isn't random either. Voyager has detected systematic variations suggesting natural radiation corridors that could represent the aftermath of ancient stellar explosions that shaped our galactic neighborhood millions of years ago. The Whispering Void. Forget everything you've heard about the silence of space. Voyager 1 has discovered that interstellar space is actually humming with constant activity. The spacecraft's plasma wave instrument detects persistent low-frequency oscillations that create a cosmic soundtrack most people will never hear. These aren't just random noise. They're organized pressure waves moving through space like invisible weather fronts. Multiple density spikes indicate Voyager is encountering shock fronts left behind by ancient supernovae that exploded thousands of years ago, with their energy still rippling through the cosmic medium. The most fascinating discovery is how layered this environment appears to be. Some regions are hotter, others denser, creating distinct climate zones in what we assumed was uniform emptiness. This cosmic weather system suggests interstellar space has its own complex meteorology. Mapping the invisible galaxy. Every data packet Voyager 1 transmits is helping scientists construct something unprecedented, a three-dimensional navigation map of interstellar space. The spacecraft has become humanity's anchor point for understanding the Milky Way's invisible infrastructure, measuring cosmic ray gradients, particle densities, and magnetic field orientations that reveal the hidden structure of our galactic neighborhood. This isn't theoretical modeling anymore. It's real-world cartography of the cosmos, like having a weather satellite for space between stars. The radiation mapping has profound implications for future human space exploration, as the intensity of interstellar radiation is far more dangerous than what astronauts encounter in Earth orbit. Understanding where natural shields and danger zones exist could determine whether humans can ever safely venture beyond our solar system, making Voyager's measurements crucial for planning humanity's next giant leap into deep space. The cloudlet highway. Since entering interstellar space, Voyager 1 has passed through at least 2 distinct interstellar cloudlets, regions where plasma, dust and gas density suddenly changes by factors of 2 to 3 times. These discoveries reveal that the space between stars resembles an ocean with currents, eddies, and weather patterns, rather than the uniform void astronomers once imagined. The probe's instruments show evidence of structured plasma ripples with clear boundaries and characteristics, suggesting large-scale organization in what scientists thought was chaos. NASA researchers now believe our sun is moving through the local interstellar cloud, with Voyager helping define its outer edges inside the much larger local bubble, an enormous cavity created by ancient supernovae explosions. These density shifts could affect Earth's exposure to cosmic radiation over millennia, as our solar system drifts through different interstellar environments, potentially influencing everything from cloud formation to biological mutation rates. The galactic boundary zone. So the transition from our solar system to interstellar space turned out to be, well, far messier and more complex than anyone predicted. Voyager 1 revealed that crossing the heliopause isn't like passing through a clean boundary. It's more like navigating a chaotic swirl of plasma, radiation and magnetic forces that shift and change as our sun moves through the galaxy at 450,000 miles per hour. The boundaries Voyager crosses aren't fixed structures but dynamic zones that evolve constantly. Magnetic fields don't align as expected, radiation environments change dramatically over short distances, and plasma waves suggest ongoing activity that scientists are only beginning to understand. This complex interstellar weather creates an environment where the edge of our solar system becomes less of an edge and more of a turbulent frontier zone, where solar and galactic influences battle for dominance in an invisible cosmic wrestling match. The ancient supernova trail. The systematic patterns Voyager 1 detects in cosmic ray intensity and plasma density aren't just random fluctuations, they're actually geological records of our galaxy's violent past, written into the very fabric of space itself. The spacecraft appears to be following trails left behind by supernova explosions that happened millions of years ago, with their shockwaves still carving out pathways through the interstellar medium. These cosmic highways, you could say, channel high-energy particles along preferred routes, and that's what creates the radiation gradients and magnetic field orientations Voyager measures. Some astrophysicists even believe these ancient stellar explosion patterns might influence where new stars form in our part of the galaxy, with magnetic field orientations potentially guiding cosmic material into denser regions that could trigger future star birth. So, the data suggests Voyager isn't just sampling local conditions, it's really giving us a glimpse into the aftermath of cataclysmic events that shaped the structure of our entire galactic neighborhood over, well, cosmic timescales. The Eternal Ambassador. While Voyager 1's scientific mission might end within a few years as its power source slowly fades, the spacecraft's journey through eternity is actually just beginning. This small probe will keep silently coasting through the cosmos long after human civilization has either evolved beyond recognition or, disappeared entirely. In about 40,000 years, Voyager will make its closest approach to Gliese 445, a red dwarf star, passing within about 1.6 light-years. It's kind of like a celestial handshake across the vastness of space. The golden record attached to Voyager carries sounds, music, greetings in 55 languages, and 116 images from Earth, all engineered to survive over 1 billion years in the harsh environment of space. This makes Voyager not just a scientific instrument, but possibly the most enduring monument humanity will ever create, carrying the essence of our species into the cosmic deep, long after Earth's continents have shifted beyond recognition. The real discovery. The most profound revelation from Voyager 1's journey isn't about discovering aliens or wormholes. It's really about understanding that interstellar space is a dynamic, structured environment all its own, with weather patterns, magnetic topography, and radiation zones. The spacecraft revealed that our solar system exists within a kind of protected oasis, with the sun's heliosphere shielding us from an environment that's way more intense and radiation-filled than anyone realized. The transition to interstellar space isn't simple, it's messy and complex, with magnetic fields that don't line up the way we expected, and plasma waves that show constant activity. The interstellar medium has layers, fronts, and boundaries that shape the invisible architecture of our galaxy. Most importantly, Voyager showed us that we live in a cosmic shelter. Our solar system isn't just our home, it's really our sanctuary in a galactic storm raging beyond our protective bubble, making Earth even more precious than we ever imagined. So there you have it. Voyager 1 didn't just reach the other side, it discovered that the other side is nothing like we expected. Which part surprised you the most about interstellar space? Let me know in the comments below. If you enjoyed learning about humanity's greatest space exploration achievement, make sure to like this video, share it with someone who loves real science as much as you do, and don't forget to subscribe to Sci and Y for more mind-blowing discoveries about our incredible universe. Until next time, keep questioning and keep exploring. When NASA's deep space monitors detected something impossible moving through the cosmic void, engineers thought their instruments had malfunctioned. But you know, the data was undeniable. 305 objects gliding in perfect formation through interstellar space, pulsing with structured signals that just defied every law of physics. After 47 years of silent travel, humanity's most distant spacecraft had stumbled upon something that challenged our understanding of the universe itself. Today on Sci and Y, we're unveiling the discovery that has NASA scientists questioning everything they thought they knew about deep space. The lonely pioneer's greatest discovery. After nearly 5 decades drifting through the cosmic void, Voyager 1 detected something that shouldn't exist, a faint signal that would change everything we know about interstellar space. Voyager 1, launched in 1977 with technology older than most smartphones, has become humanity's most distant ambassador. Traveling over 15 billion miles from Earth, this car-sized spacecraft operates in the harsh environment of interstellar space, where our sun's influence just fades into nothingness. Originally designed to study Jupiter and Saturn for just 5 years, Voyager has defied all expectations, continuing to transmit data across the cosmic darkness. Its instruments, built with 1970s technology, include magnetometers, plasma wave sensors, and cosmic ray detectors, all now serving as our first eyes and ears beyond the solar system. The spacecraft's nuclear power source, fueled by decaying plutonium, was expected to fail decades ago, yet it continues whispering back to Earth. Each radio signal takes over 22 hours to reach us, traveling at the speed of light across the vast emptiness. When Dr. Eliza Karna first noticed the anomaly in Voyager's data stream, she described it as shouting into a canyon for decades and finally something shouts back. The signal that changed everything. What began as background noise in Voyager's data stream revealed itself to be something far more extraordinary, a deliberate signal from the depths of interstellar space. The first indication something was wrong came through Voyager's plasma wave sensors. Among the usual cosmic static, a faint but persistent signal appeared, rhythmic, structured, and completely unlike anything previously recorded. NASA's Jet Propulsion Laboratory initially dismissed it as instrument noise, but the signal's behavior just defied explanation. Unlike random cosmic radiation, this anomaly showed patterns, repetition, and what appeared to be intentional modulation. Systems analyst Carlo Romero noted that the signal's characteristics resembled the kind of deliberate motion one might expect from a drone rather than a rock. The plasma readings showed organized pulses echoing through space, creating magnetic fluctuations that seemed purposeful rather than chaotic. As engineers analyzed the data more carefully, they realized this wasn't just electromagnetic interference, it was something actively moving through the interstellar medium. The signal's strength varied in ways that suggested a physical object passing by Voyager's sensors, but its behavior patterns indicated intelligence or at least sophisticated design. The discovery triggered NASA's Level 3 Alert Protocol, reserved for phenomena that don't fit within current scientific understanding. Movement that defies physics. The object wasn't just moving through space, it was accelerating, changing direction, and gliding with precision that seemed to mock every law of physics we understand. Traditional space objects follow predictable paths governed by gravity, momentum, and known forces. But this anomaly broke every rule. Dr. Lucas Hang at JPL ran simulation after simulation, trying to match the object's behavior to known models, but nothing worked. The object curved through space with deliberate precision, accelerating without any visible propulsion system. There were no engine flares, no ion trails, no heat signatures, yet Doppler shift measurements showed it moving at incredible speeds. Some readings indicated velocities exceeding the calculated escape velocity of the entire Milky Way galaxy. The object's path bent in ways that defied orbital mechanics, with no drift or decay expected from natural phenomena. It wasn't tumbling chaotically like space debris. Instead, it maintained controlled flight patterns that suggested active guidance. The movement appeared to manipulate space itself, creating ripples in the fabric of space-time that allowed forward motion without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure. The formation revelation. When scientists pulled up the complete telemetry data, they discovered something that honestly sent chills down their spines. This wasn't just one object, but 305 moving together in perfect formation. The full scope of the discovery really emerged when engineers analyzed all available data from both Voyager spacecraft. What they found just defied comprehension. 305 distinct objects moving through interstellar space in coordinated formation. Each object maintained precise relative positions to the others, gliding past Voyager 1 in what appeared to be a choreographed arc. This wasn't debris scattered randomly through space. These objects moved as a unified group, displaying organization and purpose that seemed impossible without some form of control. In the vacuum of space, groups of objects naturally spread apart over time due to gravitational influences and velocity differences. Yet these 305 objects maintained their formation with precision that suggested active coordination. Scientists compared it to watching a flock of birds or a school of fish, except this was happening in the emptiness between stars where such coordinated movement shouldn't be possible without technology. The formation itself spanned vast distances, with objects separated by thousands of miles yet moving in perfect synchronization. Each object displayed the same unusual characteristics: structured plasma pulses, magnetic field distortions, and impossible propulsion signatures. The language of the cosmos. Hidden within the plasma waves were patterns so structured and deliberate that scientists began to wonder if they were witnessing the universe's first attempt to communicate with humanity. As researchers examined the signals more closely, they discovered something that just transformed the entire investigation. The plasma wave pulses weren't random electromagnetic noise. They contained loops, sequences, and structures that resembled communication protocols. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or system. The signals showed rhythmic repetition, harmonic intervals, and organized sequences that suggested encoded information. These weren't the chaotic bursts expected from cosmic phenomena, but measured, deliberate transmissions that seemed designed to convey meaning. The waveforms resembled quantum oscillations used in modern entanglement experiments, the same signals researchers use to transmit information between particles separated by vast distances. Each of the 305 objects contributed to this cosmic symphony, broadcasting synchronized pulses that created complex interference patterns in the interstellar medium. The mathematical precision of these signals suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were using the vacuum of space itself as a communication medium, encoding data in the fabric of space-time. Earth's unexpected reception. While NASA analyzed Voyager's data, amateur radio operators across Earth began detecting the same mysterious signals, proving this phenomenon was far more powerful than anyone imagined. As Voyager transmitted its extraordinary findings back to Earth, something unexpected happened in radio stations worldwide. Amateur operators with backyard setups began reporting strange activity, weak, irregular pulses that didn't match any known terrestrial source. These weren't professional observatories or official deep space monitoring stations, but hobbyists with spare parts equipment designed to catch meteor scatter and satellite chatter. Yet somehow, they were detecting faint echoes of the same signals Voyager had recorded billions of miles away. The timing was impossible to ignore. These Earth-based detections aligned perfectly with Voyager's most intense plasma anomalies. The signals weren't strong, but they showed the same patterns and regularity that had puzzled NASA scientists. Some operators described them as ripples reflecting off invisible walls in the ionosphere, while others noted their unusual harmonic structure. The phenomenon suggested that whatever was generating these signals possessed incredible power, capable of transmitting across interstellar distances with enough strength to leak into Earth's electromagnetic spectrum. This raised troubling questions about intentionality. Was this accidental bleed-through, or was something deliberately testing Earth's listening capabilities? The historical search. Desperate for answers, NASA scientists combed through 50 years of space mission data, searching for any previous encounter with these mysterious objects, and, well, they found absolutely nothing. With mounting evidence of something unprecedented happening out there in deep space, a specialized team began examining decades of archived mission data. They searched through every deep space mission on record, Pioneer 10, Pioneer 11, New Horizons, and, countless others, looking for any hint that similar phenomena had occurred before. The investigation took them into these dusty archives containing records that hadn't been touched since the 1980s, analyzing data that had often been dismissed as background noise or just instrument error. If these 305 objects had passed through our region of space before, there should have been traces in the historical record. But the search yielded nothing. No echoes, no formations, no plasma loops in any previous mission data resembled what Voyager was currently detecting. This absence of historical precedent made the current situation even more extraordinary. The objects weren't part of a repeating cycle or a known phenomenon. They were either entirely new or had somehow remained invisible to our instruments until now. Some researchers even proposed a chilling theory. Maybe these objects had always been present but cloaked or dormant, activated only by Voyager's presence or perhaps its golden record transmission. The machine's transformation. As if the discovery wasn't strange enough, Voyager itself began changing, reconfiguring its systems in ways engineers never programmed, almost as if something had awakened within the ancient spacecraft. While scientists grappled with the implications of the 305 objects, Voyager 1 itself started exhibiting unprecedented behavior. The spacecraft's attitude and articulation control system began routing data through old, long-unused subsystems, bypassing its core software in ways that seemed almost deliberate. Engineers initially suspected a malfunction. After all, this was 47-year-old technology running on code older than most of the people analyzing it. But deeper investigation revealed something more unsettling. Voyager wasn't failing, it was reconfiguring itself. The spacecraft began reactivating memory segments that hadn't been accessed in decades, rerouting telemetry through pathways that were never part of its original programming. This behavior started immediately after one of the strongest magnetic pulses from the passing objects, suggesting a possible connection between the external phenomenon and Voyager's internal changes. The modifications were too systematic and clean to be random corruption. They appeared purposeful, as if the spacecraft was adapting to new circumstances. Engineers had to dig through dusty file cabinets at JPL, consulting 1970s paper manuals and assembly language code to understand what was happening. The quantum connection. Deep within Voyager's data streams, scientists discovered something that changed everything. The mysterious signals were using quantum entanglement principles to transmit information across impossible distances. As analysis of the plasma wave data continued, researchers made a discovery that revolutionized their understanding of the phenomenon. The structured signals weren't just organized, they exhibited characteristics of quantum entanglement, the same principles used in cutting-edge Earth-based communication experiments. The waveforms showed quantum oscillations that suggested the 305 objects were using the interstellar medium itself as a transmission network, encoding information in the fabric of space-time. This revelation opened the possibility that Voyager hadn't just stumbled upon random objects, but had intercepted part of a vast communication system spanning the galaxy. The spacecraft's analog sensors, free from the electromagnetic noise of modern digital systems, made it the perfect receiver for these quantum transmissions. Being positioned far beyond the solar system's interference, Voyager existed in an ideal listening environment, a cosmic microphone in the perfect acoustic chamber. The signals showed harmonic intervals and mathematical precision that suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were part of an ancient network, a galactic internet that had been operating for millennia undetected by human technology. The cosmic network awakens. As Voyager continues its journey through the darkness, scientists realize it may have become part of something far greater, a galactic communication network that has been waiting for humanity to finally listen. The implications of Voyager's discovery extend far beyond a simple encounter with unknown objects. Evidence suggests the spacecraft has stumbled upon, or been deliberately included in, a vast communication network that spans the galaxy. The 305 objects appear to be nodes in this system, relay stations that maintain and transmit information across interstellar distances using quantum entanglement principles. Voyager's transformation, its spontaneous reconfiguration and activation of dormant systems, might represent integration into this network, turning humanity's oldest space traveler into our first interstellar communication terminal. The structured nature of the signals, their quantum characteristics, and their perfect timing suggest this isn't a random encounter, but a deliberate contact event. Perhaps the network has been monitoring our technological development, waiting for the right moment when we possess the capability to detect and understand its transmissions. Voyager's analog design, its position beyond solar interference, and its decades of faithful service made it the ideal candidate for first contact. The spacecraft's golden record, carrying sounds and images from Earth, might have served as our credentials, proof that humanity was ready to join a larger galactic community. Voyager 1's discovery of 305 mysterious objects moving in formation through deep space represents either the greatest natural phenomenon ever recorded or humanity's first confirmed contact with non-human intelligence. As our brave little spacecraft continues its journey into the cosmic unknown, it carries with it the hopes of an entire species, and possibly our first invitation to join a galactic community. If you're fascinated by these incredible cosmic mysteries, hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more mind-bending space discoveries. Thanks for watching. Keep exploring the infinite. On September 26, 2022, NASA achieved something truly unprecedented. They deliberately crashed a spacecraft into an asteroid at 6.6 kilometers per second and, get this, completely changed its orbit. The DART mission wasn't just about proving we could hit a space rock. No, it was humanity's first successful test of planetary defense technology. But what happened after the collision honestly shocked scientists and revealed truths about asteroids that nobody really expected. The aftermath of this cosmic collision is rewriting everything we thought we knew about protecting Earth from space threats. The journey to impact. NASA's Double Asteroid Redirection Test, or DART, began its historic journey on November 24, 2021, launching from Cape Canaveral Space Launch Complex 40 atop a SpaceX Falcon 9 rocket. The refrigerator-sized spacecraft traveled for nearly 10 months across 11 million kilometers of space to reach its target, a small asteroid moonlet called Dimorphos. The mission team, led by project scientist Dr. Nancy Chabot at the Johns Hopkins Applied Physics Laboratory, had meticulously planned every detail of this unprecedented experiment. Unlike previous space missions that aimed to study celestial objects, DART was designed with one purpose: to slam into Dimorphos and change its orbital path around the larger asteroid Didymos. The spacecraft carried advanced navigation systems that would allow it to autonomously guide itself to impact during the final 4 hours of flight, since the 11-minute communication delay with Earth made real-time control totally impossible. As DART approached its target, onboard cameras captured dramatic images of the asteroid growing larger and larger, marking humanity's first intentional collision with another world for planetary defense purposes. The perfect target. Dimorphos proved to be the ideal testing ground for this groundbreaking experiment, measuring approximately 160 meters in diameter and orbiting its larger companion Didymos every 11.9 hours. The binary asteroid system, located about 11 million kilometers from Earth at the time of impact, posed no threat to our planet, making it a safe target for this high-stakes test. Didymos, the larger asteroid measuring 780 meters across, served as the gravitational anchor for its smaller moonlet. Scientists chose this system because any change in Dimorphos's orbit could be precisely measured from Earth, using ground-based telescopes and radar systems. The asteroid pair was discovered in 1996, and had been extensively studied, providing researchers with detailed baseline measurements of their orbital characteristics. The proximity of the two asteroids meant that even a small change in Dimorphos's velocity would produce a measurable shift in its orbital period around Didymos. This binary system represented the perfect natural laboratory for testing kinetic impactor technology, close enough to Earth for accurate observation, large enough to produce detectable changes, yet far enough away to ensure complete safety for our planet throughout the experiment. The moment of impact. At exactly 23:14 UTC on September 26, 2022, DART slammed into Dimorphos at a closing speed of 6.14 kilometers per second, releasing kinetic energy equivalent to approximately 2.5 tons of TNT. The collision occurred with pinpoint accuracy, striking the asteroid's surface and instantly vaporizing the 610-kilogram spacecraft along with a portion of the asteroid's rocky material. Ground-based telescopes around the world captured the dramatic moment as a brilliant flash of light erupted from the impact site, followed by an expanding cloud of debris that grew brighter over several hours. The Hubble Space Telescope and James Webb Space Telescope immediately began observing the aftermath, documenting the evolution of the ejecta plume as it stretched across thousands of kilometers of space. Within minutes of impact, the debris cloud had expanded beyond Dimorphos itself, creating a spectacular tail of material that resembled a comet's tail stretching behind the asteroid. Amateur astronomers joined professional observatories in tracking the collision's effects, witnessing history as humanity demonstrated its ability to alter the path of a celestial object. The impact created seismic waves that rippled across Dimorphos's surface, potentially reshaping the asteroid's internal structure in ways that scientists are still working to understand. Beyond all expectations. The results of the DART impact exceeded every prediction and shattered the mission's success criteria. Instead of the minimum 73-second change in orbital period that would have declared the test successful, Dimorphos's orbit around Didymos shortened by an astounding 32 minutes. This dramatic change represented a 26-fold improvement over the mission's baseline requirements, proving that kinetic impactor technology was far more effective than scientists had dared to hope. The massive orbital change resulted not just from the direct momentum transfer of the spacecraft's impact, but from the unexpected efficiency of the momentum multiplication effect created by the ejected debris. As material blasted away from the impact site, it carried additional momentum in the opposite direction, acting like a natural rocket engine that amplified the deflection effect. Dr. Tom Statler, DART program scientist at NASA, described the results as a watershed moment for planetary defense and humanity's ability to influence our cosmic environment. The orbital change was so significant that it could be measured by small telescopes and even confirmed by radar observations from Arecibo Observatory and the Goldstone Deep Space Communications Complex. This level of deflection meant that if Dimorphos had been on a collision course with Earth, the impact would have shifted its trajectory by hundreds of thousands of kilometers. The mysterious ejecta cloud. The debris cloud created by DART's impact revealed secrets about asteroid composition that puzzled scientists worldwide. Instead of the uniform dust plume that computer models predicted, the ejecta displayed complex structures including multiple debris streams, spiral patterns, and irregular particle distributions that suggested Dimorphos had a far more complex internal structure than anticipated. Dr. Christina Thomas at Northern Arizona University, who led the observational campaign, noted that the debris cloud evolved in unexpected ways over the following weeks. Some particles were ejected at speeds exceeding 500 meters per second, while others moved much more slowly, creating distinct populations of material with different trajectories and behaviors. The cloud's asymmetric shape indicated that Dimorphos wasn't a solid uniform rock, but likely a rubble pile, a loose collection of smaller rocks and boulders held together by weak gravitational forces. High-resolution images from ground-based telescopes revealed that the ejecta contained both fine dust particles and larger chunks of material, some potentially meters in size. The debris cloud's brightness variations suggested that different types of material were being ejected from various depths within the asteroid, providing unprecedented insights into the internal layering and composition of small solar system bodies. Hera's investigative mission. Recognizing the need to understand DART's impact in detail, the European Space Agency launched the Hera mission in October 2024 to conduct a comprehensive post-impact investigation. This follow-up mission represents an unprecedented example of international cooperation in planetary defense, with Hera scheduled to arrive at the Didymos system in late 2026 to examine the crater left by DART's collision. The spacecraft carries advanced instruments including high-resolution cameras, thermal imagers, and radar subsystems designed to map both asteroids down to centimeter-scale resolution. Hera will measure the precise size and depth of DART's impact crater, analyze the composition of exposed subsurface material, and determine how the impact altered the internal structure of both Dimorphos and its parent asteroid Didymos. The mission will also deploy two small CubeSats called Juventus and Milani to conduct complementary investigations, including the first radar sounding of an asteroid's interior and detailed gravitational field mapping. Dr. Patrick Michel, Hera's principal investigator, emphasized that understanding the physical properties revealed by DART's impact is crucial for designing future deflection missions. The data collected by Hera will validate computer models used to predict deflection effectiveness and provide the foundation for operational planetary defense systems. Unraveling asteroid mysteries. The DART impact revealed that small asteroids like Dimorphos are far more complex than scientists previously understood, fundamentally changing how we think about these cosmic building blocks. Pre-impact models assumed asteroids were relatively simple objects with predictable responses to external forces, but the dramatic success of the deflection demonstrated that rubble pile asteroids behave more like fluid structures than solid rocks. Dr. Andy Rivkin at the Johns Hopkins Applied Physics Laboratory noted that the impact's efficiency suggested Dimorphos has very low internal cohesion, allowing the impact energy to propagate throughout the entire structure and eject material from multiple locations. The asteroid's surface appears to be covered in loose regolith, fine, rocky debris accumulated over millions of years, that was easily disturbed by the impact's shockwaves. Spectroscopic observations of the ejecta revealed that Dimorphos contains ordinary chondrite minerals, similar to the most common meteorites found on Earth, but with unusual proportions that suggest a complex formation history. The impact also provided insights into how small asteroids respond to tidal forces from their parent bodies, with evidence suggesting that Dimorphos experiences ongoing surface changes due to its proximity to Didymos. These discoveries have profound implications for understanding asteroid evolution, the formation of binary systems, and the potential resources available on near-Earth asteroids for future space missions. Complications for future defense. While DART proved that kinetic impactors can deflect asteroids, the mission also revealed complications that will influence future planetary defense strategies. The unexpectedly large orbital change, while impressive, highlighted just how difficult it is to predict exactly how different asteroids will respond to impact. Dr. Nancy Chabot emphasized that the momentum multiplication factor, the ratio of total momentum change to the spacecraft's initial momentum, varied significantly from pre-impact predictions, reaching values between 2.2 and 4.9 depending on the measurement method. This variability means that future deflection missions will require detailed advanced characterization of target asteroids to predict their response accurately. The complex ejecta pattern suggested that asteroid internal structure, surface composition, and rotation state all influence deflection efficiency in ways that current models just don't fully capture. The discovery that small asteroids behave more like loosely bound rubble piles than solid objects means that deflection strategies must account for potentially dramatic differences in material properties between different asteroid types. Mission planners now recognize that successful planetary defense will require a library of deflection techniques tailored to specific asteroid characteristics, rather than a one-size-fits-all approach. The DART results also emphasize the importance of early detection and characterization, since deflection effectiveness depends critically on understanding an asteroid's physical properties years before any potential impact threat. Global Planetary Defense Initiative. The success of the DART mission has catalyzed unprecedented international cooperation in planetary defense, transforming what was once considered science fiction into practical space policy. NASA's Planetary Defense Coordination Office, established in 2016, now works closely with the European Space Agency, Japan's JAXA, and other international partners to develop comprehensive strategies for detecting and deflecting hazardous near-Earth objects. The United Nations Office for Outer Space Affairs has established new protocols for sharing asteroid tracking data and coordinating deflection missions, recognizing that planetary defense is a global responsibility requiring multinational collaboration. Ground-based survey telescopes like the Catalina Sky Survey in Arizona and the Linear program in New Mexico continue discovering new potentially hazardous asteroids at rates exceeding 1,000 per year, building a comprehensive catalog of objects that might someday threaten Earth. Space-based detection systems, including NASA's NEOWISE mission and the planned NEO Surveyor telescope, will dramatically improve our ability to find and track smaller asteroids that ground-based systems might miss. The establishment of the International Asteroid Warning Network ensures that discovery data reaches decision-makers quickly enough to enable deflection missions if needed. These coordinated efforts represent humanity's first serious attempt to protect our planet from cosmic threats that have caused mass extinctions throughout Earth's history. The future of planetary defense. The DART mission's spectacular success has laid the foundation for humanity's first operational planetary defense system, but it also revealed how much we still need to learn about deflecting dangerous asteroids. Future missions will build on DART's legacy by testing different deflection techniques including gravity tractors, nuclear standoff detonations, and enhanced kinetic impactors designed for specific asteroid types and threat scenarios. NASA's follow-up missions are already in development, including concepts for multi-spacecraft deflection systems that could handle larger asteroids or provide backup capabilities for critical deflection attempts. The double asteroid redirection test proved that humanity possesses the technological capability to alter the course of celestial objects, marking our species' transition from passive observers of cosmic events to active participants in shaping our solar system's dynamics. Advanced computer simulations now incorporate DART's impact data to model deflection scenarios with unprecedented accuracy, enabling mission planners to design precise interventions for specific threat asteroids. The mission's success has also sparked development of rapid response deflection technologies that could be deployed on shorter timescales for newly discovered threats. Most importantly, DART demonstrated that international cooperation and scientific expertise can overcome seemingly impossible challenges, providing a template for tackling other global threats that require coordinated human action on planetary scales. So there you have it. NASA didn't just hit an asteroid, they revolutionized planetary defense and revealed that asteroids are far stranger than we imagined. Which discovery about the DART mission surprised you the most? Let me know in the comments below. If you enjoyed learning about humanity's first successful planetary defense test, make sure to like this video, share it with someone who loves real space breakthroughs, and don't forget to subscribe to Sci and Y for more incredible discoveries about our universe. Until next time, keep exploring the cosmos.